If you take a difficult problem and hand it to a state-of-the-art AI assistant, you would naturally expect your results to improve. But a recent test found the exact opposite. This chart tracks human performance when paired with an AI helper. It shows human accuracy plummeting from 27% down to just 9% on complex tasks, while a secondary metric shows human confidence surging to 76%. People were making far more mistakes, but feeling twice as sure they were right. Researchers at 3 European universities deliberately set up a harsh environment for this study. They gave participants questions that AI models typically fail to evaluate correctly, like identifying fine visual details hidden in films, and offered an AI advisor. The most revealing shift was their willingness to admit uncertainty. Before AI, people answered "I don't know" to 44% of questions. With AI, that number collapsed to 3%. The researchers even introduced cash rewards, paying the test subjects to get the correct answers. The financial incentive produced almost zero improvement in their accuracy. The technology quietly talked humans out of their correct instincts. Instead of acting as an intellectual upgrade, the AI disabled the subject's psychological ability to recognize their own errors. That same illusion of competence is scaling up to the macro corporate level, creating a cycle of performative adoption driven entirely by job security and fear of falling behind. Take a recent report of a business executive who authored the comprehensive AI strategy for an organization valued at over $2 billion. This executive wrote the entire roadmap without ever having logged into an AI tool or tested one firsthand. Down in the engineering departments, the behavior mirrors the boardroom. Developers are using AI to rewrite perfectly functional existing code into unfamiliar languages, not because the software needs an update, but because the developers need to look busy and secure their positions. Software vendors are trapped in the exact same loop. Executives selling these tools refuse to publicly challenge impossible claims of 100 times productivity gains, knowing that pointing out the reality would undercut their own clients' credibility and threaten existing contracts. Across the board, the initial push to integrate these models is generating motion without movement. The metrics reflect a desire for the illusion of progress, rather than measurable, tested utility. Behind those inflated claims of progress lies an architecture governed by strict, invisible limits. The massive scale advertised on pricing pages often masks the financial reality of running the software. Recently, a quiet code update was pushed to OpenAI's Codex project, the tooling behind its coding models. The patch corrected the advertised memory limit for its GPT 5.6 model, reducing it from 372,000 tokens down to 272,000 tokens. A token is roughly a chunk of text, and this limit defines exactly how much data the model can hold in its short-term memory at one single time. This diagram illustrates why that specific adjustment matters. Once a user's input crosses 272,000 tokens, a hidden price line is crossed. The entire request is suddenly billed at a premium rate, roughly double the cost for input and 1.5 times for output. The old advertised limit was quietly pushing users past a premium threshold without their knowledge. Beyond artificial financial thresholds, the industry is slamming into absolute physical constraints. Last week, the Chinese startup Moonshot AI launched Kimi K3, a highly anticipated open model matching frontier-level coding abilities. Within 2 days, intense user demand exhausted the company's available graphics chips. The silicon physically couldn't process the volume of requests, forcing Moonshot to completely freeze all new subscriptions to protect the servers for existing users. The promise of an infinite, ever-expanding digital mind is constrained by the very physical reality of copper, silicon bottlenecks, and unforgiving billing tiers. Because of those constraints, serious engineering teams are quietly pulling back from flashy cloud applications. They are prioritizing mundane reliability. Take Claude Code, the tool powering millions of developer sessions. In a recent update, it completely swapped its underlying engine to a Rust-based core. The shift made the tool about 10% faster on Linux, but otherwise the change was entirely invisible to users. The explicit goal of the rewrite was simply to make the application boring and reliable. That same pragmatic approach is taking over the enterprise data sector. Major corporations possess highly sensitive regulatory and financial data, and they strictly refuse to upload it to third-party public AI services. Instead of relying on centralized, heavy public cloud infrastructure, they are bringing the processing in-house. They are trained a small, localized model on its own crop science data, turning complex queries that used to take weeks into answers generated in under 30 seconds. Discovery Bank did the same with its financial formats, cutting response times down to a fraction of a second. For regulated industries, raw intelligence is losing its value. The deciding factor for enterprise power is absolute control over data privacy and the speed of localized hardware. This demand for control is accelerating the open weight movement. General-purpose models like GLM 5.2 and specialized document readers like Baidu's Unlimited OCR are currently dominating download charts, easily beating out newer, larger competitors. The appeal is straightforward. If you download the full weights of a model, you bypass the subscription lines, avoid the hidden API fees, and run the system completely offline on your own machines. Simultaneously, the software used to run these local models is rapidly maturing. A new local runtime called BaseRT recently launched, claiming to process models 6.4 times faster than previous standards on consumer hardware. Engineers are measuring these local deployments against a new standard. Benchmarks like Alipay P-Bench grade AI agents on genuinely difficult real-world tasks, like correctly wiring up a payment system, unglamorous work where a tiny mistake costs real money. The industry is pivoting away from hype and toward hard utility. But whether a model is running in a massive data center or locally on your laptop, the core challenge remains. When an AI can effortlessly deliver a highly confident wrong answer, the most valuable skill in the modern economy is the human willingness to pause, doubt, and verify the facts.